Oh, yeah. Right, so quickly finishing up this section, we have our definition of a function, which you can't really see very well. Let's change that. There we go. We talked about functions. We know how to determine if something is a function, and we looked at how to graph them using like plotting points, basically. And then we talked about the domain, which is what we're really focusing on. I know that we're finding the range as well. On tests and quizzes, I'm usually just going to ask you what the domain of a function is, mainly because graphing a function takes a while if you don't already know how to graph it using the tools we'll have later in the semester. But when I talked about domains, I said the two main things that restrict the domain or make it smaller than just all the real numbers is when we have square roots. Remember, the inside of a square root has to be positive or 0. And we also talked about denominators. Denominators make things a little bit tricky too, okay? We dealt with how to find the domain of square roots functions. So whenever there's a square root in there, we kind of know how to find the domain. We played around with finding the range, but I told you not to worry about it too much, okay? Then we started talking about the denominators, okay? And what we realized about denominators is we can't divide by anything that's 0, okay? So whenever we have a function and we want to find the domain of it, we're going to take the denominator, we're going to set it equal to 0 and see what happens, okay? Now, I got a good question last class about the numerator. The numerator doesn't really matter here, okay? So when we're finding the domain, don't worry about what the numerator says. It could really be anything. Just worry about what the denominator says, okay? So what I want to do is do a little bit of a larger example than what we did before. And I might want to talk about the homework a little bit after this too, okay? So example 16, it says we want to find the domain and range of 5 over x minus 7, okay? With this example, we need to find the domain first, right? Domain. And to find the domain, we're going to take the denominator, set it equal to 0. So what's our denominator here? X minus 7, good. I'm going to set that not equal to 0. Kind of weird to see that, but and to solve for x, we're just going to add 7 on both sides. So x does not equal 7. What this means is everything else in the domain works, but 7. Okay. Anyone remember how to write this in set builder notation? Using our brackets and parentheses. Yeah, something that looks like this from our last page, right? Anyone can kind of see how we can translate the last example to set builder notation in this example? Perfect. -infinity and 7 and 7 to infinity. Okay. Talking about brackets, am I going to have any brackets here? No, right? Infinities never get brackets. They always get parentheses. And the 7 isn't included because it's not equal to 7. So actually everything is going to get the parentheses. Okay. Now, if you're looking at WebAssign, WebAssign is probably going to use this notation here, a little U in between. All that sign means is and. Okay, so -infinity to 7 and 7 to infinity. So the domain wasn't that hard. Since this question does ask for range, let's go over that. I promise you, in the future, graphing this will be a little bit easier than just plugging in points. But why don't we just do it to see what happens? Okay. So I said the best way to find the range is to draw a picture. Okay, and we don't have any tools to draw this picture except for plotting points at this point. So I'm just going to put in some x points and f of x, see what happens. Okay. Now I can choose any point that I want here. I think I'm going to start with what the domain says and kind of work my way outwards. And the way I'm going to do that is I'm going to put 7 in the middle here. Okay. And I'm going to try to plug it in, even though I know it's not going to work. Okay. So I know that f of 7 is 5 over 7 minus 7 That doesn't work, right? That wouldn't work in our calculator. It would give us 5/0, which doesn't work. Okay. Working backwards from here, I guess I can plug in numbers above 7 and numbers below 7 and see what happens around this area. Okay. So it looks like let's try x equals 6, right? 6 is a good option for us. Okay. So that would be 5/6 minus 7. And I'm going to move the 6 up so you guys can see it better. Okay. 6 minus 7 is -1. So this is -5. I know that we have -5 at 6. Okay. I guess I can plug in 8, right? 8 would also work because that's a little bit after 7. And I'd get 5/8 minus 7, 5/1, which is +5. Okay. Now, at this point, I actually have enough information to graph my function because I kind of know what this function is going to look like, okay? Any function that looks like this with x in the denominator is going to look like this function. It's going to have this shape, okay? So I know I can plug in some more points, and you can do that if you want. I'm going to show you how I would draw this with the 2 points I have, okay? If I have this very badly drawn axes, okay? Maybe I should make it a little further to the right here. Let me draw my x and y axis with the positive x values a little bit more. We've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay, at x equals 7, I don't have anything. It looks like it doesn't work. Looking at the last graph of 1/x, what do you think is going to be on the graph at x equals 7? Take a look at the graph here. It starts with an A. An asymptote, right? So this graph is going to look very similar to the graph beforehand because all these graphs have the same shape, which means they both have asymptotes. And asymptotes arise when the function doesn't really exist, okay? So it looks like we're going to have a vertical asymptote at x equals 7. Okay. Now later on, we're going to actually deal with drawing this a little bit in a more intelligent way than what I'm doing here. So bear with me as we go on. Looks like we have a point at 6, -5. So 6, 1, 2, 3, 4, 5, -5. We've got a point here. Okay. And at 8, let's see, we got 1, 2, 3, 4, 5. Looks like we have a point here. Okay. Now, I kind of know what the graph looks like now. I know it's going to have that shape, and I know it's going to go down. Looking at what we have so far, I'm not actually sure how far down this function is going to go, right? So maybe I should plot a few more points and see what happens, right? I know that this graph kind of gets closer and closer to the vertical asymptote, but I don't know what it gets closer and closer as we go to the left and to the right. Okay, so why don't we plug in 5? 5 is a good one, right? We already plotted 6 and 8. This would give us 5/5 minus 7, which is -5/2. Plugging that in, let me do that for you guys. We get -2.5. Okay, so at 5, we have -2.5. Okay, so maybe my graph isn't very well drawn, but now it's kind of looking like this. Oh my goodness. Okay. Let's keep going. I know I didn't give enough space, but let's go up here. I can plug in 4, right? And that would give me 5/4 minus 7, which is 5/3. I'm going to do that in my calculator. That would be -1.67. So that would be here. Okay. Going a little bit further, I could plug in 0 just to see where this graph is going. And that would be 5 over -7, which would be 0.17, which would be over here. Okay. As I continue drawing this graph, do you kind of see where this function is getting closer and closer to, but not touching? Where do you think it's not touching? Do you think it would cross the x-axis? No, right? It looks like this graph is getting closer and closer and closer to the x-axis, but it's never actually going to touch it. Okay. Now, on the other hand, on the other side, I can plug in more points and find the same thing. These graphs are actually vaguely symmetrical. So if it does it on one side, I'm just going to continue on the trend on the other side and have it get closer and closer and closer to the x-axis, but never touch it on the right side too. Okay. So looks like we have our graph. We graphed our domain already. Now we want to find the range. Looking at this picture, what value do you think, or what y value do you think the function doesn't take on here? Zero, right? At y equals 0 on the y-axis, so let me kind of get to it here. If I'm sitting on the y-axis and I look to the right and to the left, there's going to be no picture there because the function never actually reaches the x-axis, right? So at y equals 0, nothing happens. So y can't equal 0. Okay. What's another way to say y can't be equal to 0 in set builder notation? Looks like this. That's another way to write y is not equal to 0. Perfect. And we're going to put all of those in parentheses because we're not actually reaching 0, and infinities don't get brackets, right? All right. Any questions on what I've just done here? Okay. If the range was a little confusing, I wouldn't get too upset about it. I'm probably not going to ask you on range. Definitely know how to find the domain though. Okay, so what I'm going to do is I'm going to give you a couple minutes to work on example number 17. We'll work on that for a little bit and we'll come back in a tiny bit. All right, I know some of us are still drawing, but as we continue on, Allison, do you kind of want to explain how you got the domain?
Yeah, so I just said whatever was not equal to 0, which would be, yeah, x minus 5. Add 5 and x does not equal 5. So I put it.
Perfect. As I was walking around, I saw some good answers here. Now, of course, you can try to draw the function yourself. In the next section, we'll actually learn how to draw this a little bit faster than just plugging in points. But taking a look at our range, what did we get for the range? What value didn't work for the range? That was the domain. What y value wouldn't work? 0, right? Because if I'm sit at y equals 0, I look to the right and to the left, that's where the function is. The reason it isn't 5 is because if I go up 5 and I'm sitting on the y-axis and I look from the right to the left, there actually is a value y equals 5, right? So 5 actually would work, 0 doesn't work, and 0 actually is the only thing that doesn't work here. Okay, so same thing as the last question. Our range is going to be -infinity to 0 and 0 to positive infinity. Any questions on example 17? Okay, before we go on, I want to tell you one more thing about the homework. Okay, so I'm going to make a little thing here. I'm going to write homework. I took a peek at your homework yesterday, and I saw a question that looks a little bit different than what we've been doing so far. I think it was like f of x equals, I think it was like 10 over like x squared. Let me try one that I know, plus 2x minus 1. No, let's do plus 1. Yeah. Okay. Now, looking at this, okay, that's not similar to what the other questions were. The other ones just had one x in the denominator, okay? So if I wanted to find the domain of this function, I would have to set the denominator equal to 0, right? But how would I solve this one? Yeah, we'd factor it, right? So this is just a quadratic equation. You can still solve it, but it's a little bit harder. Okay, so we'd have to factor it. We'd have to find things that add to which number? 2, good. And multiply to what number? 1, good. And what two numbers do that? 1 and 1. This was kind of a bad example. I wanted to give one where there were multiple ones. Okay, let me change this up a little bit. Why is this hard for me right now? Let's do x squared minus x. No, that wouldn't work either. Okay, let me do something real quick. For some reason, I can't think well on the spot. X minus 1. I think minus 2 would work. Okay, let's try that. Let's change up the question a little bit so we get two different numbers. Okay. In this case, we'd find two numbers that add to -1 and multiply to -2. What two numbers would work here? -2 and 1. Okay, so I just wanted different numbers here. Okay, sticking these into my factors, it looks like my two factors would be x plus 2 and x minus 1. No. I don't know why my brain isn't. X minus 2 and x plus 1 does not equal 0. Okay. This is what happens when you try to come up with an example on the spot here. Okay. Setting each of our individual factors equal to 0, we get x minus 2 does not equal 0. X plus 1 does not equal 0. And we get that x can't be 2 and x can't be -1. Okay. So now I have two things that won't work here. Anyone want to guess what the set builder notation would look like here? Well, if I graphed my answers, it's basically saying that everything works except for 2 and -1, right? So this is a very bad graph, but 2, 3, 1, 0, -1. Okay. If I were to graph my answers, I know that -1 wouldn't work, so it would have an open circle. I know that 2 wouldn't work, so that would have an open circle. But everything else would work, so everything would have a line. Okay. So if I were to write this in set builder notation, we have 3 different chunks, right? I know that everything from -1 and below works. So that would be, let me write this out in a different color, -infinity to -1, right? So that would represent this part of my error. To represent the middle part, it would be -1 to 2. Right? And finally, to represent the last part, or this arrow, it'd be 3 to +infinity. Okay. Oh, sorry, 2. Sorry about that. Thanks, Stephen. 2 to +infinity. Okay. Now, we want to include all of these at once, so we have to put our u's in between. Okay. This is what the domain would look like if we had two things that didn't work. Are we good with seeing that on the homework? Oh, what?
I had a question. It was like this, except there were no numbers. It was like, okay, it was functional notation, and I wanted us to plug something in for x, but something was like x minus h. square all over H and is it probably something?
Yeah, let me see that real quick. Is it webassign.com? I'll just look at webassign. And let me go here real quick. Actually, no, I don't want to do that. All right, hang tight, everyone on Zoom. Oh my gosh. Okay, and I'm just going to add an extra page here. Okay, let's take a look at this homework, which I clicked the wrong one on. Yeah, so this is just an example, but the question, I'm just going to rewrite the question on my iPad real quick. It was 7x minus 3, and we wanted to find f of a plus h minus f of a all over h. Okay. So let's go back to what I wrote down here. Okay. So let me get you started on this. Okay. And I'm just going to write this a little bit neater. Okay. The reason WebAssign asks you this is because if you ever take calculus, you will see this multiple times throughout the semester. So this is something that you plug in very often in calculus, which is why WebAssign asks it. Okay. Since we have two things being asked, why don't we just find what each of the parts are? Okay. So taking a look at my function, what do you think f of a plus h would be? How would I plug that in? Perfect. 7a plus h minus 3, right? Whatever is in the parentheses gets substituted in for x. Okay, so instead of writing x, I wrote a plus h, and I put it in parentheses because it's a group of things and I don't want to get it mixed up with everything else. Okay, I guess we can kind of simplify this by expanding this. So this would be 7a plus 7h minus 3, right? Okay. I think that's as far as we can go with the f of a plus h part, right? Okay. Let me write this in blue next. Okay. Next, we know f of a. This one's a little bit easier. What do you think f of a is? What's f of a, looking at my function? Yeah, instead of writing x, I'm going to write a. 7a minus 3. Okay, so whatever goes in the parentheses goes in for x. Okay. Now that I have these parts, well, I know I have to subtract them. So I'm just going to do f of a plus h, which is 7a plus 7h minus 3. That was f of a plus h, right? Okay. I know that I'm subtracting off f of a, and I should probably put in parentheses because I'm subtracting off an entire group of items. So minus 7a minus 3, and this is f of a. And I'm putting it all over h, which was already in the question, right? So all over h. Okay, does that make sense so far? All right. Well, why don't we just kind of finish this one up? What should I do to simplify this? What would be my first step here? I think I heard you say it. We can, but since there's like parentheses going on here, I might not want to do that first. Yeah, distribute the negative might be my first idea. I think I see what you're saying, but I make mistakes if I do that without doing this first. So I'm going to take this negative sign and distribute it. And this becomes 7a plus 7h minus 3 minus 7a minus, plus 3, right? Over h. Okay. And once I'm here, like Robert said, we can group together the terms, right? So it looks like there is a 7a and a minus 7a. Well, those get canceled out. Okay. Looks like there's a 7h, but there's nothing else. So I guess I can write the 7h, right? And then there's a 3, -3, and a +3. Those cancel out. Okay, so all I'm left with on the top is 7h. On the bottom, there's an h. What can I do now? I don't think you can do 7h for h, but I think I heard it. Yeah, you can just cancel out the h's, right? Yeah, that was easy. Way better than that, right? So our answer is actually just 7. Okay. Yeah, so this formula actually is really, your answer should be pretty simple when you do this with any sort of polynomial function. Your answer should be a pretty simple value. Any questions on this one? Do we feel a little bit better about that homework question? Good. All right. Looks like I want to start a new set of guided notes, if that's all right with you guys. Probably not, but don't have a choice. I know. All right. So the new set of guided notes looks like, I don't think this is in your packet. So new set of guided notes looks like this. I'm going to pass these out real quick. Actually, gonna go 1, 2. There you go. All right. So in this section, we're going to learn how to draw graphs a lot faster than how we've been doing it before. Remember when we were doing the square root function and the 1/x function? Graphing it took a while because we had to plot a bunch of points, kind of know the shape and like connect the dots, and it was just really hard. Took a lot of time, and we want to do it a little bit faster. Okay. So the way we go about this faster is we're going to learn about several different common graphs that you're going to see a lot. And the good thing about these graphs is that they all have the same shape, no matter what they look like. Okay, so we're going to start very simple. We're going to know what these graphs look like, and then we're going to do this thing called a transformation to these functions, which is going to make them look a little bit different, but they're going to essentially have the same shape. Okay, yeah, you know where we're going. All right, so we're going to draw these graphs here. When I draw these graphs, you're going to have to memorize what these look like. And the way you're going to memorize it is you're going to know the common points on the graph. So there's going to be very specific points. I'm going to want you to know how where they are on the graph, given the function. And I'm also going to show you what the shape looks like. Okay. All right, let's start. Our first function is the constant function. And it looks like this. It has the form f of x, which is just our y value, equals c. Okay, so for example, f of x equals 2 would be a constant function at 2. Okay, and if you ever get confused as to how to draw a graph using the function notation, you can always replace f of x with y. Okay, so you can always say y equals 2 instead of f of x equals 2, if that makes it a little bit easier. Okay, so y equals 2. Think back to your lines example or your lines section. Y equals 2, is that a horizontal line or a vertical line? Horizontal or vertical? It's a horizontal line, right? Because y is always 2, and it actually doesn't matter where y is 2, because at any x value, y is going to be 2, right? So this is basically a horizontal line at the height y equals 2. Okay. So for this function, I'm not going to tell you to memorize any specific point because, well, it should be 2 everywhere, right? And I could give you y equals 3 or y equals 4, and it would just be at a different height on the graph. Okay. All right. think we're pretty good with the constant function. Let's get a little bit harder. Next, we have the linear function, which we've done a lot of work on, right? This function is f of x equals x, right? And I think we know how to draw this. This is a graph with y-intercept 0 and slope 1, right? So it's just going to go up diagonally like this. Okay, so this graph, if I look at my point here, it's going to look like this. Oh, that's not going to work. Nice. Oh, that's pretty good. Now, it should look a little bit better than what I just drew, but.
No, mine looks pretty
All right. This is good that this is an art class. That works. Okay. So whenever I ask you to draw a linear function like this, I definitely want you to plot 0, 0. I want you to plot that point in the origin. And I want you to put, I think the easiest one to do is to draw this point here, 1, 1. Those are 2 points I want to see on the graph if I ever ask you to draw this graph. I also want the shape to be a straight diagonal line. Okay. I think we're doing pretty good so far. Let's continue on to the quadratic function. Okay. All right, here's functions that we haven't really dealt with before. I know we've been doing a little work with this, but we haven't dealt with the graph too much. Okay. Now this graph, anyone know what the shape is called? Starts with a P. It's a parabola, right? It looks like a U, okay? And if I'm drawing this graph, before we even draw it, I guess I can plot some points and see what actually happens, right? So if I have my X and Y values, when X equals 0, Y would be 0 squared, which is 0, right? So I know that 0, 0 is on this graph, okay? When X is -1, what's Y? 1, right? Because -1 squared is +1. So we've got this point on the graph, okay? And then 1 would be 1 squared is 1, okay? When I draw the quadratic function, these are the 3 points I definitely want to see on the graph, okay? Now, of course, you can plot 2 and -2 and get 4 and +4 again, okay, to make the full quadratic shape. But when you draw this graph, oh gosh, I want to see these 3 points on the graph. That's what I'm going to be looking for, okay? And I definitely want to see the U shape on the graph as well. Okay. So far, nothing too weird. We've seen these graphs multiple times before in this class. Let's go a little bit to some of these graphs that we haven't seen before. Okay. The absolute value function. Now, we talked about this function before. We know what the absolute value means. Who remembers what it means? What does the absolute value symbol do to a number?
It turns it into a positive.
Yeah, it makes it positive, right? So like the absolute value of -3 would be +3, for example. Okay, now let's say I don't know how to draw this graph yet. I can plot some points. Absolute value of 0, well, 0 is not really positive or negative, that would just be 0. The absolute value of -1 is 1, and the absolute value of 1 is 1. Good. Okay, so I got 3 points on here that I already know are on the graph. We can plot more points. For example, the absolute value of -2 is 2, right? So this point would be on here. And I think as we see, yeah, it's gonna look like a little V, right? Perfect. Okay. Now, because this V shape is going to be very straight on both sides, it's not going to be curved like a parabola anymore. It's actually just going to be a very straight graph where we go up here and we go up. Oh my goodness, that's really bad. Let's see, go up this way. Okay, so it's basically the quadratic function, but instead of looking like a U, it looks like a V. When you draw this graph, I am looking for the point at 0. I want these 2 points and I want the shape, Okay, so those are the 3 things or 4 things I'm looking for. Any question on the absolute value function? All right, and it brings back memories from high school, right?
Yeah, I took 3 calc, so
Yeah.
I hated it.
Yeah, these graphs show up all the time. Can't get away from them, especially if you go into calculus. Not the best thing to do, but it works. And it makes our lives a little bit easier. Okay. Square root function. We've looked at this function in the domain and range section. Let's see. Let me ask this in a better way. What can't I plug into the square root function? Negative numbers, right? Can't plug in -1, -2. So let's just start at 0. Let's plug in some 0 values. What's the square root of 0? 0. Okay, moving on. I guess we got 1. What's the square root of 1? 1. What's the square root of, let me jump to 4.
2.
2. Good. So as we continue building our points, I'm not going to do any more. You're okay. Let's plot our 3 points, 0, 0, 1, 1, 4, 2. Okay. And I don't know if you remember from last section, but this looks like a parabola, but cut in half, right? So it's going to look like this. It's going to expand like that. When I ask you to draw the square root function, I want you to draw this point, 0, and I want you to plot 1, 1. I'm not really looking for 4, 2. I think that's a little bit too much to memorize if you're quickly sketching the graph, but I'm definitely looking for those 2 points and the shape. Okay. Good so far. So far. All right. The 1/x function that we just dealt with today. This is the function that has 2 of the weird word that we've been talking about. What is that weird word that comes about with the 1/x function? Asymptotes, right? So this one has 2 asymptotes that I need you to draw whenever I ask you to draw this function. And with 1/x, it's pretty easy. It's just the x-axis and the y-axis, right? So I want you to draw the asymptotes. And in order to denote that, most mathematicians use dotted lines. So I want you to draw them with dotted lines. Okay, so that's what I'm looking for when I'm asking you to draw this function. Okay, now I'm not going to go over this too much because we did this in the last section. We got 1, 1 and -1, -1, right? These are the only 2 points I need you to know because you know that this graph gets closer and closer to the y-axis and closer to the x-axis in this specific shape. Okay. Okay. So whenever we're drawing the 1/x function, this is the shape that we're looking for. And I want you to draw the asymptotes and also these 2 points. Okay. Any questions so far? Okay. All right, this is the 1/x² function, and I did a very bad job of writing out this function because I have a caret symbol in it. Okay, but this function is not 1/x, it's actually 1/x². So whenever there's a quadratic in the denominator. Let's see what happens with this function. Okay, so if you don't remember how to draw the graph, you can always plot some x and y points and plot them. Okay, I'm never going to take off points for you plugging in points and seeing what the output is. Okay, what happens when we plug in like x = 0?
No.
No, right? It'd be 1/0², which is 1/0. That doesn't work, right? So what do you think is going to happen at x = 0?
It's not gonna touch.
Yep, asymptote not going to touch the function. Looks like we have an asymptote at x = 0. Okay, and I know it's kind of hard to find out too much, but there's actually an asymptote at the x-axis as well. Okay, so these I also want you to draw the asymptotes. Okay, let's find out what the other points on this graph are. Okay, at 1, what is 1 over 1 squared? 1, right? What about -1? What's 1 over -1 squared?
One.
1, right? Because -1 squared is 1. 1 over 1 is 1. Okay, so I've got 2 points in this graph. I've got 1 and -1. This is actually enough to draw the function, right? I know that my graph is going to get closer and closer to the y-axis or the x-axis and closer to the y-axis. On the other side, I know it's going to do the same thing, but in a different direction. Okay, so whenever you draw the graph of 1 over x squared, you're going to draw these 2 points. You're going to make sure it has the shapes, and you're going to make sure that you drew the asymptotes as well. Okay, so these 2 functions, the 1 over x and 1 over x squared functions, look very similar, except that one of them has no negative parts, right? Because, well, we have a square. Okay. Any questions so far? All right. Let's do the last one real quick. We have the cubic function. We can plug in some values. Okay. We've got 0. What happens when we cube 0? 0. What happens when we cube -1?
1.
Ooh. -1, right? An odd power keeps the sign, and 1 becomes 1. Okay, so we got 0, 1, 1, -1, oop, -1, good. Okay. We can continue drawing some values, but it actually will go off the scope of this page. So I'm just going to show you what this one looks like. Anyone know what this one looks like?
Yeah, it's like the.
Yeah, it's like a disco man, right? So it looks like a disco man with one of his arms going up and another one of his arms going down. Okay. Whenever you draw this graph, I'm looking for 0, 0, the points at 1 and -1, and the shape of the disco man. Any questions about drawing these graphs? Yeah. So for example, like the 1 over x function, x squared. Well, if I try to plug in 0, right, I get 1 over 0 squared, which is 1 over 0. If you just type that in your calculator, it's going to give you an error symbol. So it's going to say error, which means, yeah. It just try in your calculator. If it doesn't work, then it's not going to happen at 0. Does that work? Yeah. It does not explode, but I can imagine it doing it. All right, if we don't have any more questions, I will pick up on this next class. And I will see you tomorrow.
Sayonara.
Sayonara.